It is a pleasure to welcome you today. For those of you who don't know me, my name is Enrique Lugo, and I'm a senior nanotechnology student at the Center of Nanotechnology from the National Autonomous University of Mexico. Let me begin with my presentation. As we all may know, nowadays electrical devices such as smartphones, computers, TVs, and so on tend to be more compact, enhancing characteristics such as battery duration, better camera and screen quality, and I let your imagination run wild. These enhancements I just mentioned are because of the miniaturization of the electrical components of the device. I'm talking about components with the size of 1,000th of a Hertz diameter. For example, a carbon nanotube. But I found a problem here. We all have the infrastructure to fabricate carbon nanotubes. But how can we guarantee their capability of truly being electrical components? Let's stop here. First of all, once the carbon nanotubes are fabricated, we need to measure their electrical properties. For example, resistivity or conductivity. The question here is how can we measure these properties of such small components? Well, the answer I proposed is by fabricating a device that will allow us to connect the carbon nanotubes to the macro world. And you may ask yourself, what is the macro world you're talking about? Well, it's us, the smartphones we use, for example. We found that it is simple to fabricate this measuring device I'm talking about. The technique we used is called photolithography. In simple words, it is a process that transfers patterns from a mask onto a surface by using light. Finally, after using photolithography, we obtain what we call a 4-prof electrical contact. But there is still work to do. The challenge now is to find a method to lay and weld a single nanotube onto the surface of the 4-prof electrical contact. Thank you.